fire locks the grain of the steel in place. This is how the foundation of this project is a solid bar of 80 CRV2 high-carbon steel. Known for its exceptional toughness and edge retention, it is an ideal alloy for heavy-duty use. The initial profile is traced directly onto the mill scale. Establishing these lines early ensures the blade geometry stays balanced before the aggressive stock removal begins. Cutting the blank loose with a grinder generates intense friction. Keeping the cut line close to a water bucket prevents the metal from overheating and ruining its temper prematurely. Moving to the belt sander, the transition between the handle, the cutting edge is fine. This plunge line dictates how stress travels through the knife during heavy impact. A small sharpening notch, or choil, is carved into the ricasso. This separation allows future sharpening stones to reach the very base of the edge without riding up the transition. Bringing the steel into the forge completely alters its crystalline structure. At bright orange temperatures, the rigid carbon matrix becomes plastic, allowing the hammer to compress and stretch the material rather than simply grinding it away. Forging the primary bevels packs the steel grain closer together. This mechanical compression along the cutting edge adds structural density that simple stock removal cannot match. Working the hot steel requires a rhythm that balances heat loss against metal displacement. As the blade cools, it darkens, signaling the anvil strikes must stop before the steel becomes too brittle. Each precise blow draws the metal thinner, extending the blade's profile outward. The anvil does the shaping. A filing jig establishes a perfectly flat plane across the forged bevel. Draw filing by hand removes the remaining hammer marks and sets a true geometric angle before the final heat treatment. The heat treat is the most critical phase of the build. Returning to the forge, the steel is brought just past its critical temperature where it loses magnetism. Plunging it into oil rapidly extracts the heat, freezing the carbon atoms into a hardened state. A quick bake in the tempering oven relieves internal stress, preventing the newly hardened edge from shattering. With the steel successfully tempered, refining the tang ensures a flush mating surface for the handle material. Any high spots left here would create weak points in the grip assembly. The transition area near the bolster requires careful attention. A smooth, sweeping curve prevents sharp right angles, which are notorious for harboring hidden stress rises, where a blade is most likely to snap. A pass on the buffing wheel erases the micropuck sanding scratches, leaving a highly polished, corrosion-resistant surface. The focus now shifts from cold metallurgy to the warm geometry of the handle. A paper template provides a flexible way to visualize proportions before committing to expensive materials. Translating the tang dimensions to paper ensures the overall balance point of the knife remains centered right at the index finger. The foundation of the handle is a solid brass guard. Scribing exact boundary lines into the soft metal provides a hard physical track to follow during the rough cut. Brass is highly machinable, but builds heat quickly, requiring steady pressure to prevent the grinder from wandering. Drilling out the center channel removes the bulk of the waste, making it easier to file the slot to its final dimension. Pressing the guard onto the tang requires a tight friction fit. This mechanical seal blocks moisture from creeping under the wood layer, preventing internal rust that could destroy the knife from the inside out. With the guard seated, the internal pin layout is established. A thin brass backing plate is drilled to match the tang holes precisely. These internal plates act as structural spacers, spreading the clamping force of the pins across a wider surface area. Without them, the natural expansion and contraction of the wood over time could crack the handle scales at their anchor points. The rough scales are leveled on the belt sander. Achieving perfectly flat inner faces ensures an invisible glue line when clamped against the metal tang. The handle features a composite structure utilizing contrasting wood tones. Cutting the blocks square guarantees they will mate seamlessly without gaps. Boring the central channel requires a slow feed rate to keep the drill bit from wandering off-center through the end grain. A final locking pinhole is drilled completely through the assembled dry fit block. This anchors the multiple layers together, tying the wooden components directly to the hidden steel tang. Pressing the two wood species together over the tang creates the core grip profile. Wrapping the joint in masking tape protects the porous end grain from absorbing stray adhesive or oil during the rough shaping process. Taking the block to the belt sander rapidly removes the sharp, square corners. Blending the light and dark wood requires a delicate touch as the different densities will sand away at varying rates. The goal here is to establish the primary ergonomic curves, creating a smooth transition that feels natural in the palm while indexing the blade alignment. Pinholes are finalized through the exterior scales, locking the geometry in place. Sanding the side profile thins the handle to its finest width. Removing material from the sides reduces the overall weight and prevents the handle from feeling too bulky, ensuring the knife moves nimbly in the hand. Tactile feedback, allowing the builders to feel high spots and shapes the finger grooves to match the natural mechanics of a human grip. Hand sanding progressively closes the wood grain, erasing file marks and bringing up a smooth, tactile finish. A final touch on the belt restores the micro bevel of the cutting edge. Heavy brass rod is severed to serve as the structural pin. The pins carry the shear forces of the handle, ensuring the wood layers cannot slide past one another. Cupping the ends slightly with a drill bit allows the pins to flare and lock into the wood when keen. A wooden block distributes the vice pressure evenly across the curved scales, preventing indentations while the epoxy cures. Once the chemical bond sets, a hacksaw quickly decapitates the protruding brass pins, bringing them flush with the wood surface. A coat of structural epoxy seals the end grain before the solid brass pommel is attached. The brass cap acts as a counterweight, shifting the balance of the heavy steel blade back toward the rear of the hand. A final retaining pin mechanically secures the entire span. Slack belt provides the final buffing pass. The flexible abrasive wraps around the handle's organic contours without flattening the carefully shaped curve. Friction generates heat, drawing the natural oils of the wood to the surface to create a rich, durable luster. Taping the handle prevents stray grit from marring the finish while the bolster is refined. Peeling the masking tape is a moment of truth. It reveals the sharp, precise contrast between the dark polished wood and the gleaming metal hardware, proving the transitions are completely seamless. A hollow lanyard tube is drilled through the base. This provides a secure tie-off point for field use, adding a final layer of utility to the finished handle block. Working with heavy tooling leather requires a different pace. A thin, even bead of contact cement is laid along the edges. Unlike standard glues, contact adhesive must become tacky before the parts are joined, creating an instant, unbreakable bond the moment the two faces meet. Plastic clamps apply uniform pressure along the welt, ensuring the layers compress tightly without leaving metal indentations in the soft hide. Once the adhesive cures, the raw edges are sealed with a dark brown dye. This isn't just aesthetic. The dye penetrates the porous fibers, hardening the edge and preventing moisture from causing the leather to swell and rot during outdoor use. The material demands patience. After saddle stitching the perimeter, the synthetic thread is melted flush. Fusing the ends locks the stitch in place, ensuring the seam will never unravel under tension. The heavy basket weave tooling provides rigidity to the leather shell. A manual press sets the brass snap hardware into the retention strap. The mechanical die crushes the tubular rivet perfectly evenly, securing the metal into the leather without tearing the fibers. The strap is permanently anchored to the main sheath body with a solid brass rivet. This retention system acts as the primary safety, holding the heavy blade securely during movement. The sharp snap of brass confirms the fit. What began as a rough bar of high-carbon steel is now a precise, balanced tool. The organic warmth of the wood and leather grounds the cold geometry of the metal. True craftsmanship endures.